Hi, we're going to begin our Chapter 7, which is about solving systems of equations by looking at something that we're familiar with already, which is solving systems in two variables. Really, you've learned three methods for solving systems: graphing, substitution, and elimination. But and this is my opinion, I believe that at this level, elimination is probably the best way to go. So I'm going to focus on the elimination method. If you want to use a different method, of course, you're welcome to do that. But if we're going to solve this system of equations, elimination wants you or asks you to manipulate the equations by multiplying so that when you add the two together, you can eliminate one variable. And our little helper over here is saying, if we multiply the top equation by 4, we would end up having plus 4y here and minus 4y here, and those we'd be able to eliminate when we add. So the idea is to multiply by some number so that when you add the two equations, one variable disappears. I'm going to put the result of my multiplication here. That's 12x minus 4y equals 40. And I'm going to rewrite the other equation just so I keep my clarity here. The idea in elimination is to add those two equations together. So 13x's, negative 4y, positive 4y, y's are eliminated, which is what we want. On the other side, 52. And then divide by 13 to find our x. X will be 4 because 52 divided by 13 is 4. Once you know y, you substitute that back into one of the original equations, folks. Don't go here. Go back here, one of the original equations, and use it to find your y. So I'm going to put it in the bottom one, which said x plus 4y. So our x is 4. 4 plus 4y then must equal 12. Subtracting and then dividing, y has to equal 2. And what we have found then is the solution set for this system of equations. It consists of the point where x is 4 and y is 2. That is the only value that they will share in common. I'd like us to do just a quick review of the possibilities that can occur when you're solving systems of two equations in two variables. A system like this, the one that we just solved, has one solution. Which makes it consistent. We're going to introduce some vocabulary here. ... Consistent means it has solutions. Consistent because it has solutions. Since it has exactly one solution, it's also called independent because there's only one solution. So if we have a system where two lines intersect in one point, we can say that system is both consistent and independent. Has a solution, has only one solution. The second set of lines here, the parallel lines, well, these are never going to meet. There's never going to be a solution to this. So this is no solution, or zero solutions, if you will. That means that it is inconsistent. There is no solution. And since there is no solution, talking about dependence or independence doesn't make sense. Okay? In this situation, both the blue and red line have combined to make purple, and that means that you have many solutions. Okay? Infinitely many solutions, because you were basically talking about the same line. This thing, since it has many solutions, is consistent. It has to have, in order to be called consistent, you have to have solutions. This one, since it has many solutions, is dependent. Okay? Dependent because there's more than one. And if you wanted to write other notes, of course, these two lines are parallel, and these two lines were the same line. So let's take a look at this and wrap it up. In the previous example, yada yada yada, some have many solutions, some have no solution. And in this particular example, I can see that I could eliminate if I multiply the top equation by 2, so I'm going to do that. I'm going to put my work underneath. That would give me 10x minus 4y equaling 8. And when you do the adding step, now we're going to add here because these are our two equations. We get 0 on this side because 10x and the y's cancel as well. 0 equals 15. Now you know that that is not true. Okay? 0 does not equal 15. That's an indicator that there is no solution to this. When you get to a fact that cannot possibly be true, that means there is no solution, or you have an inconsistent system. In this one, we need to rearrange that equation. Let's bring the 4y's over on the other side. So x minus 4y would equal negative 8. And if we wanted to eliminate here, multiplying by negative 5 would do it. That would get rid of the x's. So that would give us negative 5x plus 20y equals 40. And when you combine that with what we had above, 5x minus 20y equals negative 40, you can see right off the bat you're going to have 0 equaling 0. That is a true fact. Okay? So when you come up with something that is truth, then that means that you have many solutions, or you have a dependent system. For an application problem, I've chosen a mixture problem. These are frequent uses for solutions of two equations and two variables. We have a chemist who needs to mix, it says, an 18% acidic solution with a 45% acidic solution in order to obtain 12 liters of a 36% solution. And then the question is, how many liters of each of the acid solutions have to be used? We have two of them. You have an 18% and a 45% solution. So if we let x equal the number of liters of the 18% solution, and y equal the number of liters of the other 45%, then I think we can come up with a couple of equations. X is the number of liters of one, y is the number of liters of the other. And as far as quantity goes, we have to come up with 12 liters altogether. So x plus y must equal 12. As far as concentration goes, now we got to think about this a little bit. We're using x liters of an 18% solution, so we're going to have 0.18x. We're using y liters of a 0.45 solution, so 0.45y. And we want the overall concentration to be 36%. We know that we need 12 liters altogether. So now we've got two equations, two variables. We can do a little simplifying here. Okay, I'm going to rewrite and simplify at the same time. X plus y equals 12 is our first equation. The next is 0.18x plus 0.45y equals, and 36 times 12.12 is 4.32. Alright, now we're ready to start doing our elimination. If we multiply our top equation by negative 0.18, we could get rid of x's, and I'm going to show that down below. So I'm negative 0.18x minus 0.18y equals, that is 2.16, equals 2.16, and that will be negative. Alright, now we are ready to do the elimination step, and I'm going to bring my word down here since it says solve down here. The x's have gone, and we have 0.45 minus 0.18, so 27 I think. 0.27y will equal, doing the subtracting, that's going to be 2.16, and dividing 2.16 by 0.27, 8. Y is equal to 8 when we divide. Once we know y, then we can go back to the original equation and find x. In this case, x and y have to equal 12, so x must be 4. And we're going to answer this question by saying the chemist needs, right? We should always answer a question with a sentence. The chemist needs 8 liters of the 45% solution and 4 liters of the 18% solution. So a little mixture problem to get us started here. And lastly, we want to talk a little bit about break-even analysis, and this again is something that you've done before. Folks, to break even, that means that a company's revenue or their income has to equal cost. See, there's no other way for you to break even other than what you sell covers how much it costs you to produce it. Revenue, well, that's the number of units that you sell, so units sold times the price per unit. So if you sold 50 of them and they were $10 each, $500 would be your revenue. Cost can come in 2 forms. All businesses have fixed costs, and those are things like rent and utilities, things that you have to pay no matter how much product you produce. Fixed costs plus cost per unit. So costs come in 2 forms, revenue just the one. To make a profit, profit's more than just breaking even. So in order to make a profit, revenues have to be greater than costs. And let's take a look at this little problem. A company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They're sold at $80 per pair. Determine how many pairs, here's our variable, how many pairs of shoes the company must sell to break even. So X is the number of pairs, and we want to break even in this problem. So we have to set up our revenue, which would be the number of units sold, that's our X, times their price per unit, that's 80. So 80X, that's our revenue, must equal $300,000 in fixed costs plus $30 per pair of shoe, or 30X. This isn't even 2 variables, 2 equations. You can write a single equation for this. Subtract 30X from both sides. 50X is the same thing as 300,000. And dividing by 50, it would be 6,000. X is 6,000. Let's answer the question, how many pairs of shoes they must sell. 6,000 pairs of shoes to break even. And that's our lesson for today. I hope we've had an enjoyable time going down memory lane, right, from our algebra classes. Try the U-Try, and we'll see you in school.